Okay, the next part is concentrations of solutions. Concentrations of solution is done in terms, its unit is moles per dm cube. Okay, we will take straight away an example for this. Suppose we are having here 9.8 grams of sulfuric acid, that is H2SO4. This is dissolved in water and its aqueous solution whose total volume is say 500 centimeter cube. Okay, so what I've done here in this case, I've taken 9.8 grams of sulfuric acid H2SO4 and we are dissolving it in water, and the volume of the total volume of the solution of sulfuric acid in water is 500 centimeter cube. Now how are we going to calculate its concentration in terms of moles per dm cube? First of all, we will have to get the moles. Okay, moles, how do we get? This is going to be grams divided by RMM. That's the molecular mass. The grams over here is 9.8 divided by the molecular mass of sulfuric acid. Okay, sulfuric acid is H2SO4. So this is 2 into 1. You can get the atomic masses from the periodic table. Plus sulfur is 32. Plus oxygen will be 16 into 4. Okay, this all is going to add up. It's going to make 98. So the relative molecular mass of sulfuric acid is 98. So this is going to be, first we are going to calculate here the number of moles, which is grams divided by the molecular mass. So 9.8 divided by 98, this is going to become 0.1 moles. Okay, now this concentration is in moles per dm cube. The volume that we are given over here is in centimeter cube. So this centimeter cube will have to be converted into dm cube. We'll have to divide it by 1000. So this is going to become 500 upon 1000, which is going to become 0.5 dm cube. Now concentration is equal to moles divided by its volume, which is supposed to be in dm cube. The number of moles over here, as we have calculated over here, is 0.1 divided by the volume in dm cube we have calculated here, which is 0.5. Okay, this, if I'm going to calculate using a calculator, it is going to be 0.2. So the final answer is going to be concentration of this solution of sulfuric acid is equal to 0.2 moles per dm cube, which is also written as 0.2 capital M. Let's take down these example and then we are going to take several examples. So this is our next example. Calculate concentration of the solution. 16 grams of NaOH. NaOH is sodium hydroxide, which is a solid. It is dissolved in water and we are getting 400 centimeter cube of its solution and we are supposed to calculate its concentration. Okay, so our formula is again going to remain the same. Concentration is equal to the number of moles divided by its volume, which is supposed to be in dm cube. Okay, so first of all I'm going to get the number of moles of NaOH. Okay, so sodium hydroxide, the molecular mass we are going to calculate first, that is NaOH. These atomic masses you will get from the periodic table. Na is 23, oxygen is 16, plus hydrogen is 1. So the RMM of NaOH that we are getting is 40. So now number of moles of NaOH, this is equal to, okay, the number, the mass, that is the grams, which is going to be 16 grams divided by its relative molecular mass, which is 40. Okay, this, if you are going to divide, it's going to become 0.4 moles. Now this is the volume that is given to us in centimeter cube. We are supposed to convert this in dm cube. This we'll do it by dividing by 1000. Okay, so 400 divided by 1000, this is again going to become 0.4 dm cube. Okay, so concentration of the solution, that is moles divided by volume per dm cube. Moles we have calculated here, it is 0.4 moles divided by, okay, its volume, that is supposed to be in dm cube, which we have calculated here, which is 0.4. 0.4 upon 0.4 will be 1. So the concentration of this solution is 1 mole per dm cube. This is equal to, okay, this is also written as 1 capital M. Take down this example and then I will give you practice examples.
Sir, it's okay if I write concentration equals to moles.
Okay, so instead of writing this formula, moles upon volume in dm cube, you can also write, if it is given in centimeter cube, instead of dividing it by 1000 over here, I can write here moles is equal to moles multiplied by 1000 divided by volume, that is in centimeter cube. Just take down these examples and then I'll give you practice work. Okay, so these are the practice examples. Calculate the concentration of the following solutions. 18.9 grams of nitric acid in 600 centimeter cube of its solution. 7.3 grams of hydrochloric acid in 2 dm cube of its solution. And the third example is 90 grams of glucose in 1.6 dm cube of its solution. Just take down this much part and then you will do those examples and you will send it to me. I'll check them right now. Okay, the formula of nitric acid is HNO3. Hydrochloric acid is HCl.
C6H6.
Glucose, the formula is C612.
H12 and O6.
Okay, the atomic masses.
In exam it will be given to us, sir.
The formula, all formulae will not be given to you. Some of the formulae you need to know. For example, nitric acid, hydrochloric acid, glucose, all these are common examples. Some uncommon examples are there, that formula will be given to you.
So what is the formula? We don't know formula then.
If you don't know formula, then you will not be able to work out. Common formula you should know. Those which are not there in the syllabus, that formula they will give you. Okay, the atomic masses, hydrogen, all this you will get from the periodic table. Hydrogen is 1, nitrogen is 14, oxygen is 16, chlorine is 35.5, carbon is 12. You can start doing them. This is the next example that you are supposed to solve. 10 grams of iron 3 sulfate is dissolved to make it solution of 500 centimeter cube of its solution.